Welcome to my kcse revision channel, Teacher James Marita, Grigos Boys High School. Kindly subscribe my channel, click the notification bell such that you get notified once I upload a new video. Today we are looking at kcse revision, that's Organic Chemistry 1, and we are looking methods of gas collection represented by the alkane, alkene, and alkyne. So I have the three diagrams here. The first one is the laboratory preparation of ethene. The second one is the laboratory preparation of ethyne. And the third one is the laboratory preparation of ethane. What are some of the expected questions or the expected questions you are expecting from this particular diagram? For example, in our first case, we have this is the laboratory preparation of ethene. In this case, you need to understand the reagents which is used for the preparation of the gas, the methods of the gas collection, and also you can also go ahead and you talk of how can you confirm that the gas produced is ethane. So in that case here, for the preparation of ethene, first of all you have a reaction between a concentrated sulfuric acid and ethanol. So you have this concentrated sulfuric acid, and then you will have ethanol there. Then you have sodium hydroxide. In this case, you need to understand or to know what is the purpose of sodium hydroxide in this experiment. And then from there, you have methods of the gas collection. As you can see from this diagram, that this ethene gas is collected by the downward displacement of water, or what we call over water method. And of course, you are supposed to know the property that makes this gas to be collected by this method. Then we have the broken porcelain or sand. What of course the purpose here? You understand that a reaction between ethanol and a concentrated sulfuric acid is highly exothermic. Therefore, a layer of sand or a broken porcelain is placed here to absorb the excess heat, which might break this flask. Now, from this diagram now, in the first diagram, we have ethanol and the concentrated sulfuric acid. So you will have ethanol here, then in the presence of a concentrated sulfuric acid, so you have in the presence of a sulfuric acid here, in the presence of a concentrated sulfuric acid will remove the water molecules. And if the water molecules will be removed from ethanol, you remain with ethene gas, which is 2 carbon and 2 hydrogen, and then of course we have water. This type of reaction here, whereby the concentrated sulfuric acid removes water and the water elements from a substance, is called dehydration. So the conditions for this dehydration one, there must be a temperature of which is ranging between 160 to 180. In an examination, if you are required to give the condition here, you are not required to give as this temperature, as this range. That one is wrong. You cannot score. So when you are required to give the condition in an examination, mention a temperature of 160, 170, 180. In an examination, the range is not required. Now, if you want the reagent used here, in this case, we have a concentrated sulfuric acid. What is the role of the broken porcelain or the sand? The role of this one here, it prevents the pumping of the solution, which may break the flask. So this one will just prevent the pumping of the solution, which may break the flask. Then number two, the purpose of this sand or the porcelain, it is to ensure the uniform and smooth boiling of the mixture. So of course you can have a sources of heat here. So you will have a sources of heat. Such that now we have the role of that one is normally to ensure a uniform and a smooth boiling of the mixture. Now here we have a sodium hydroxide. What is the purpose of sodium hydroxide? The purpose of sodium hydroxide, it is to remove the carbon dioxide or sulfur oxide. Correct. That is what we are supposed to say about the roles of sodium hydroxide. We have in our second diagram, there is the preparation of ethyne. Ethyne is is an hydrocarbon which contains two carbon and of course in this case two hydrogen. A reagent which is used for the preparation of this one, of course, you will have water and calcium carbide as a solid. So you have calcium carbide and then you will have water. You need to note this one very well, that the reagent which is used for the preparation of ethane is a solid of calcium carbide and water. So if you have calcium carbide reacting with water, you will get, that is ethane gas with the two carbons and the two hydrogen, and of course we have the calcium hydroxide there. And again there is a layer of sand. What do we have here? We are talking about calcium carbide plus sand. What is the purpose of sand here? Of course, here in this experiment, the purpose of sand, it is to absorb excess heat, preventing the reaction flask from breaking. That is the reason why we have the sand there. Then we have in this reaction where we have the water and the calcium carbide, copper 2 sulfate is used as a catalyst. So copper 2 sulfate is used to speed up the reaction. So in this case here, if you come across the copper 2 sulfate in this experiment, you are supposed to know that the copper 2 sulfate here, it is used as a catalyst in this case, which in this case whereby it is used to speed up the rate of the reaction. What is now the precaution required while carrying out this experiment? This experiment, the flask must be dry. The flask must be dry before the start of the experiment. That is a precaution, a very important part. That the flask must be dry before the start of the experiment to avoid the formation of the gas before the setup is complete. That is a precaution which is required in this experiment. That the flask must be dry before the start of the experiment to avoid the formation of the gas before the setup is complete. So equation of reaction is that. And again we have the last part whereby we are talking about now the preparation of ethane. Preparation of ethane in this case, ethane sometimes this gas is called ethylene. So this gas ethane, so the gas of this gas ethane, sometimes this gas is called ethylene. So sometimes the name of this gas is also called ethylene. The reagent now required for the preparation of this ethane or ethylene gas is heating a mixture of sodium propanoate and soda lime. Soda lime is normally sodium hydroxide. Then you will have now sodium propanoate and soda lime, which is in this case sodium hydroxide. So when you are heating that one, you will have sodium propanoate and sodium hydroxide. In this case, sodium hydroxide here, it is the one which is called soda lime. And in this case, you will have a quicklime. So we have quicklime here. Quicklime is normally, we have quicklime. A quicklime is a calcium oxide. And the purpose of this calcium oxide here, it is to keep the liquid sodium hydroxide dry. So we have this quicklime here in that case. The purpose of this calcium oxide here, which is a quicklime, it is to make sure that the sodium hydroxide remains dry. Therefore, this reaction will take place in these two conditions. A condition of a quicklime here, which ensures that sodium hydroxide remains dry, and then we have a temperature which is 300 degrees. And in this case now, the reaction will take place whereby this the carbon here, the COO sodium, in this case here, is replaced by this hydrogen to form this ethane, which is 2 carbon and 6 hydrogen. Then you will have now that this COO sodium will combine with the sodium hydroxide here on this side, and that is why now we have the formation of a byproduct of sodium carbonate. We have other various methods which can be used for the preparation of this gas. The first one, as you can see here, it is heating a mixture of sodium propanoate and soda lime. So we have another method. Other methods, for example, is a reaction between a concentrated sulfuric acid and ethanol. So a concentrated sulfuric acid and ethanol, so you have a reaction between a concentrated sulfuric acid here, a concentrated sulfuric acid, and in this case, ethanol. So we have a concentrated sulfuric acid and ethanol. Ethanol sometimes is called ethyl alcohol. So this one also you can say that this one is a ethyl alcohol. So you have this is ethyl alcohol. So that is another method of preparing this ethane gas, whereby the concentrated sulfuric acid is used as a dehydrating agent. It can remove water and the water molecules from a substance, and then we remain with that ethane gas. In that case now, you can also have another method of preparing this ethane gas, whereby heating substances like kerosene and also heating candle. So when the kerosene or candle is being heated, they can also produce that. They can also produce ethane gas. So another thing that you are supposed to understand that the gallium oxide, this one here, it is called the quicklime. This one is called quicklime. We have this one as called quicklime, or sometimes this one can also be called pantheline. So you can have this one as pantheline. So if you get those words here, so we have the calcium oxide. It can also be called the quicklime, or it can also be called the pantheline, and the soda line is the calcium hydroxide. So you understand the purpose of the calcium oxide in this experiment, and then of course you understand the purpose of this calcium hydroxide. And again now in this experiment is that one precaution that you are supposed to take, that the delivery tube in this case, the delivery tube should be removed immediately heating is over to prevent the sucking back. That is a precaution. Then from there, the gas is collected by the downward displacement of water. That is a simple summary of the preparation of this gas, whereby we have ethene. Ethene, this one you will get you can get this one a class of organic compound of alkene. So you get this one in alkene. This one you will get in alkyne. So you have that one as alkyne, and this one you will get in a class of organic compound, in this case called alkane. So that is a summary of the preparation of these three gases in the lab. Don't forget to subscribe, share, and watch.